The next presentation, we're pleased to welcome Tom Rigg from B4RN, who's going to speak about the resilient network that you have there. There's lots of great content coming up here, and so I'll welcome Tom to the stage.
Right, okay. Hopefully something a little different. I'll explain a little bit about B4RN, what we're about, what we're doing at the moment, and a little bit of a deeper dive into one of the projects we're running, which is introducing 400 gig into the north of England for a residential network, and all the things that come with that, all the engineering challenges, and also the link with LINX. I've got I dug into my archives and had all the cacti graphs, etc., that I found from years gone by. So we'll look into all of that. So who are we? So we are a community benefit society. Many of you have probably already seen some of the things that we're doing, but essentially we work with communities that are deeply rural and don't have, decent internet. Now there's a big drive with Project Gigabit at the moment, which we're engaged with. A lot of other altnets are engaged with. It's a big booming industry at the moment. And for us, one of the elements at our heart is making sure that the network really does work. Okay, we've got to go and build new fiber to new properties, and it looks, talk about technology first before I go into the build. But what we want to make sure is that engineering is at the heart of what we do, because we want to make sure that the customers get the best possible experience. So some of the choices that we've made, we actually use point-to-point Ethernet for our customer connections. We don't use PON, XGS PON, etc. Our customers are very spread across a region. So one property might be 500 meters away from the cab, the next one might be 15 kilometers away from the cab, and so on. So using point-to-point Ethernet, very, very flexible, a little bit more expensive, fine, but at the end of the day, we can get the port density in our cabinets right for the amount of people we want to connect and the amount of active equipment and bandwidth available in those cabinets. So you can just go to 10 gig if you like. So what we've got here is a quick speed test on 10 gig, bidirectional optics back into the access switches. Those then go onto the backbone, head down to Manchester, or Leeds, or Newcastle, or eventually London. So all our customers are actually north of Manchester. So south of Manchester for us is south, right? So this is the build of the network. So behind all of that, we have a lot of trench in the ground. The infographic, which we did some months ago now, we built the stat for the amount of meters in the ground from the amount of orders on the system. So 5 million meters of duct that's gone into the ground. That's all been populated with fiber, connecting everybody. We have about 13,000 live customers on the network right now at gigabit, up and down, unrestricted. And this all comes through this. So it's a combination of what's called vibratory mole plow, with streetworks, of course. When you go into the village centres, you need to dig up the pavements, fine. But the majority of the network is trenched. Okay, and that goes at walking pace. That machine in the bottom left there, that goes at walking pace and gets the duct into the ground, and off you go. And then, of course, you get met by, the locals. So we've got there a cow coming in and visiting the chamber. So you've got to make sure when you're working in deep rural, there are lots of different things to do rather than just protecting your streetworks. Okay, so this is how we connect the customers. Again, we're working on the streets, in the pavements, in the chambers there, but we're also working, with chambers that are in agricultural land as well, with relatively easy or difficult access. But the great thing here is we don't use connectorized solutions. It's all spliced all the way, so very, very low losses on the network. The only patch is at the customer end and the cabinet end, and so on. So that's a bit of a quick run through how we build a network. And the one thing here is we're building and operating all of our own fiber. So, we use BTPIA in certain instances to get across a motorway, etc. But we don't use third parties to get access to the customers. So that means you can build the core and you can build the access to the customers the way you want to. Greater flexibility. Enter the Halo project. So we've called it the Halo project because the map on the right-hand side, we're creating a ring in the north of England. So that goes from Manchester up to Carlisle and Penrith, across to Newcastle, down to Leeds, back into Manchester. Previously, we had a network that went up to Data Vita in Glasgow and across to Edinburgh to LINX Scotland. We still do have a connection there, and we do still peer there, but we've had to pull all our gear back and invest it into this ring here. That's where all our customers are. So we've partnered with Zayo, of course, for the dark fiber and for the 100 gig wavelengths, and we're using Smart Optics for the fiber drivers and Juniper for the routers. So I'll go into a little bit more about that now. We had quite a big design session with all the different vendors, the different teams, and you know, I'll tell you that using some of the Smart Optics gear has revolutionized how we actually, you know, plumb and engineer the DWDM network. It uses a fleet of these pieces of equipment. Now, the top one, the DCP-M40, is in 1U, and it's everything together, right? So anybody who's worked on DWDM systems, you know, you have your EDFA amps, your preamps, you have your dispersion compensation modules, you have your mux demux, and you've got to attenuate whatever's coming in, whatever's coming out. You've got to balance that line in order to have a bundle of 10 gigs or whatever you like across it. So our current network is that. We have chassis with all these individual units in them, and the guys have had to manually attenuate all of the add drops, you know, whatever's coming in, whatever's going out. It's got to be balanced, and if it's wrong, it tears the whole thing down. Whereas nowadays, I think it's just magic, right? All of this is now in 1U, and it does it for you, right? So you plug your lines in, and it sees what light level this is coming in at, and then it says, right, well, I need it to be here, so I'm going to attenuate that, send it into the line system, and then the output is completely balanced, right? So fantastic stuff. For me, I do still think training the engineering teams and having them involved in how all this works is super important, because we were forced to do that with the first iteration of the network, which I'll go into later with the traffic snaps. But you know, 2016 was when we put our bonded 10 gig system in, and the guys had to learn it. They had to learn how it all works in order to get it all patched and working. Nowadays, you can just plug and play. That's great, but I do still, you know, really want all the engineering teams to understand how it all works. So if something goes wrong, they'll go, I know what's happening here. I know what that, you know, the fundamentals behind it, so I can see that problem is something to do with this, and off they can go and help fix it. So these are the fiber drivers that are dotted across the network. Some of the engineering challenges will come soon when you're trying to deploy deep rural network where there are no data centers, there are no exchanges or POPs that you can just pop into. Juniper gear, I mean, preaching to the converted in this room, you know, everybody's seen this type of hardware. These things are great. You know, we've gone from the MX480, 240 platforms onto the MX304, the ACX instead of the QFX, etc. And it just, you know, it's going to revolutionize how we bring that 400 gig east-west or north-south into the network. You know, and then, you know, push out the aggregation. We can go 100 gig out to all our distribution nodes, and from then you've got full access to be able to sell 10 gig services, 1 gig services over the top of that. And you've got no problems with contention or congestion or anything else like that. You've got a very high ceiling on the backbone network. Okay, and we've pushed the QFXs further down the network. We're currently using those. They're really still very useful pieces of kit where you can, you know, pull in 100 gigs and pop them out as 10s. So they're being pushed further into the network, which is great. Let's reuse those. So this project, you know, we've spent many, many months putting it together, and lead times were fun, I'll say. You know, we've had to wait a long, long time to get the gear in, but so be it. So recently, in the last couple of months, it was go time. So this is when we had the delivery of all the gear. The engineers got super excited, as they do. Everything got ripped out of its box. You had to slow them down. No, come on, asset tag it, get it in the system, and then get it racked up and make sure that you know, you've got the latest firmware, you know, JTAC recommended firmware on it. Do all of that first before you go play with it. But you know, they've thoroughly enjoyed getting that gear in and labbing it up, etc. Okay, but there are engineering challenges. Okay, I'll skip to the bottom of this slide first. There's always the usual ones, your default challenges of getting wayleaves, getting permissions, doing all the civil engineering, getting the power into these cabinets, you know, getting your funding and investment together, and then I mentioned lead times for the gear. That all has to be sorted, right? So you've done, you know, months of work before this, before the gear arrives. When it arrives, everything's ready, and off it goes just into the field and gets deployed. But there's a huge amount of work that goes on behind it. But one of the things for us is our customers are very deeply rural. I've said that a few times, but I really mean it. It's at the top of the hills in the Lake District, okay, or the Peak District, okay. Now these are farmhouses that are 5-6 kilometers away from the nearest road. So what we've done is we've put a fiber in all the way up to them. Okay, we don't do fixed wireless access. We don't recommend, oh, just go to Starlink or something like that. We say, no, come on. We'll get the community together and we'll help fund going all the way up that track to you with a full fiber. And what they do, the community comes together and they go and put that fiber in. But what that means is that they're very far away from any of the nearest, big core POPs or exchanges or whatever else. So where do you locate this gear? Well, for us, because we're building and operating all our own dark fiber, we can locate that wherever we like. So what we've done is we've tried to push the core as close to the customers as possible, which means that we're popping up these big green Rainford's cabinets, which are 600 mil deep, 25 U high, 3 bays or so long, and that's where all the gear can get racked up. Environmentally controlled with fans, heater systems, you name it in there. But that's getting pushed all the way to the edge almost. So all this gear that's, supposed to be in the DCs or in exchanges in controlled environments, we're pushing the boundary of that and sticking it out into the freezing countryside. So that's one, getting the equipment to fit into the cabinets, keeping the equipment environmentally happy, which we have been running Rainford's cabinets for over 12 years, and you'll see a snip in a little bit about one of those getting changed out, and yeah, no leaks, all the equipment's happy. But then the other thing is distributing the traffic loading between these regional areas and making sure that where you're putting your backhaul in, you can then distribute that to your customers and send it all back to the DCs quickly. So the solution, you've got to be creative, very, very creative with the technologies available, right? So, run a standard BGP core backbone network, absolutely fine, no problem. But how about using EVPN VXLAN to, distribute across sites? Instead of the top of rack switches, okay, in the data center racks, well, imagine those top of rack switches are now distributed kilometers away from each other, but you can still run the same technology because it's all your own dark fiber. So think about these sorts of things to try and get, a greater level of resilience, redundancy in there. So if a node dies, then everything will move to the other node. Or if we get a fiber strike, then everything just, gracefully moves out of the way and just carries on. Things like that. Be creative with it. Because again, engineering practices are, at the heart of what we do. So one of the things we had to do was exchange a cabinet, and one of the big reasons is the early ones didn't have rear door access. So how do you get to the power supplies at the back of the kit? You can't. So what we had to do is change the cabinet out for one with rear door access. So yeah, if you can imagine almost full exchange worth of core network equipment and customer connections, you're basically going to unbolt that, and then you're going to put a new one on and rebuild it. What does it look like? It looks a little bit like this, okay? So this was put together by the team, and that's a before. Okay, so that's about 12 years worth of patching. So what they're going to do is they're going to plumb everything out of this. They're going to prep the new cabinet and get it ready. There's been months of work coming up before this, because what you've got to do is you've got to contact all of your customers. You've got to have the back-end systems in place where you've moved all the traffic away. You've moved all the aggregation links away. And a huge raft of other things that need to happen in order to turn a supernode off, as we call them. Okay, so this is the engineers. Imagine the Benny Hill tune going, we can't do it, copyright, but that's what they were doing, working really, really hard, lots of engineers on the ground, and that's the result. Okay, so, customer patching on the left, core on the right. So this node is now ready for us to pop in the smart optics gear, the Juniper gear, and it will just get racked up. The power supplies are ready, and then the guys can just plumb it in and off you go. Okay, and one thing we're keen on is monitoring and telemetry. Right, so we really want to know what is happening when we're doing these works, as well as proactively monitoring the entire network. So this was great. Okay, I was one step removed from this. I watched it all happen, which was absolutely fantastic. Okay, Luke, as head of technical ops, is here. This was his thing. His team set all this up and ran the whole operation, and it was spotless. Right, but here's an example. So this television screen is in the NOC, and what they did is they did a live stream to the site. Okay, so then they can just communicate with each other, see what was going on, and if there are any problems, everybody knew about it immediately. And then you had the mobile knock. So you had the back of a van, that's a high-top Ford Transit van, where they then had all the laptops and the gear set out, so they can do everything from their end. And these are the guys that are actually consoled into the kit directly on site, out-of-band monitoring. They're directly plugged into that. And then on that screen, you can see the number of customers that we had to repatch that day, and when they went down, and when they recovered, and which ones didn't. Because they're having to do over 800 splices on this job, right? To tear the cables out of the cabinet and put the cables all back in again. What if one of those splices failed, right? So what they've done is they've put a monitoring system in to see when that customer gets patched. They'll see the MAC address pop back up onto the network. Is it live again? Does it have his IP? Is it provisioned properly? Yes, no. And if no, the help desk team will call or find out what the problem is, because no matter how many times you say to customers, we're doing a network at risk, it's going to go down, don't touch anything, right? Because we want everything to just stay the same. So when we do the works, we can compare like for like. But that rarely happens. Customers, the internet's off, I'll just reboot it. Oh, I'll just leave it off for a while. And then when you get everything come back on again, you think, that's not the same number we started with, what's gone wrong? And then you find out that actually, oh no, I just turned it off. Thanks. Anyway, monitoring telemetry, really, really important. Anybody spot the LINX sticker? This was not on purpose, but the guys on site had the laptop right in front of the camera, and there's a LINX sticker on the laptop. I thought it was a brilliant little tedious link back to the LINX. So a bit more on monitoring telemetry again. I really like this stuff. We're using a big suite of open source gear. Grafana has been the biggest revelation for us, plugging that into LibreNMS, and even our connection stats, they're all in Grafana now as well. And being able to monitor the power systems. What's the health of the batteries? How long are they going to last when the power goes out? Because it happens often when you're in the north and you get brownouts because it's all power over poles, etc. You've got to weather that. You've got to make sure the cabs stay online. So how long are they going to stay online for? So yeah, the team are developing this in-house. I think that's also really important. We've had experiences of trying to outsource things, and from my personal point of view, that didn't work. That didn't work for us. So instead, what we've done is we've invested in the teams, invested in the training, get the teams on board so they can get things done themselves. They're in full control of what they want, how they want to do it, and off they go. And I hope that they can come to these meetings, they can share their homework, if you like, and what they've been doing, and say, look, we did this. How does that sit? And then somebody might go, oh, I didn't think of that. I'm going to do that. And then you exchange ideas between you. I like that's the way that it works. As a community, we can all come together and make sure the internet is better. So monitoring, I love it. So now a little bit of a deeper dive into our traffic growth and our relationship with LINX, because you go back to 2014, this was 2 years after we started. So 2012, first connections, we did 50 connections in the first year. Yes. Right, and the next year we added more and more and more. So that's the 2014 traffic stats. So we have transit in the top left, we have LINX London on the right, which was actually just a long line into the port. We didn't have any rack space, we didn't have anything. We got, I think it was a Zayo 10 gig at the time that was literally into Telehouse North, then a cross patch into the LINX port, done. Because we knew from the beginning we needed to invest in this, because we didn't want to just chuck everything out of transit. We wanted to make sure that all the customers connecting could get access directly to peering, we believed. And then you've got IX Manchester, as it was then, in the bottom right. What's that, 1.5 meg? Woohoo! Okay, but that was us connecting in again in its early days. IX Manchester, I think it was born in 2012, so that's a couple of years in. And then, so that's our total traffic. There's a 10 gig there from the core in Manchester to our node. That was it. 10 gig for the backbone. Nothing else. You jump a few years to 2016, and again, you can still see that you've got, transit, and then you've got IX Manchester now pulling a little bit more weight. But even so, the main core, 4 times 10 gig now bonded to Manchester. Okay, that was what was needed. We're running at 1.4. But the majority of traffic was going to transit still, 20% to peering. But this was when everything was growing. You know, all the content providers weren't quite there yet in the north in Manchester. And so a lot of the traffic, I don't know why I didn't have a London snip on there of what was happening in LINX London. But, you know, still everything was London-centric. But we had all these things in place because we knew, well, we hoped that there was going to be investment into Manchester and then we can build on things. So you skip about 5 years and you get to the 2021 traffic snaps. Now, you know, there's a gap in between there. I must have some traffic snips somewhere, but I'm not going to bore you with all of those. But now, the majority of traffic is to peering. So we had 10% transit, 90% peering. You know, I still value a really solid transit link. You know, we're taking 100 gig with Zayo in Manchester, and that's really good. That's very well connected. And we're also taking Colt in Newcastle at 100 gig as well. That's also very well connected. So you've always got to have that path of last resort for whatever happens. But I just like seeing that, you know, what we've done is we've contacted various different people and said, look, can we peer with you? Can we get a P&I with you? You know, can we get all these links in place where we can send that traffic that way? Because we're both in control. We're not at the mercy of sending it out through a transit provider that might have a few paths to get somewhere. It's very good nowadays, but having control of those links is just second to none. What if you had packet loss? You know, I had an example once where a ferrule on a fiber connector was like 0.5 mil out because the spring clip had broken in it. And so it's still linked, but you had high loss on one way. So, you know, the transmit might be fine one way, but the receive on the other was not. But that was causing us real problems, and nobody could find it. Nobody could find this thing, you know, on the network. And so we were just seeing packet loss problems just pop up. And then one day it was fixed, and then one day it wasn't. And so we just couldn't use it, so we had to move the traffic away. So having lots of different links, lots of different peers, lots of different options is absolutely the way to go. So then you go again, another couple of years to sometime this year where we've got another traffic snip. So it's grown almost double again in a couple of years. And this is, you know, growth in the network, connecting more customers, but actually people using the internet more. Okay, that is happening. If you have 13,000 unrestricted gigabit ports on the network and people are going to do bursty things on it, that's going to start to go up. So we're seeing the traffic trends, you know, more and more usage on the network. So we kind of had to act now. We triggered the Halo project about 12 months ago now, at least, I think, to say we're going to need this in the future. And thankfully, it's in delivery now because, you know, our core of the network is already 10% of the first 400 gig wave. Right? That might not seem very much right now, but you go back to when we started and we had 1 times 10 gig with a few hundred meg on it. Okay, grow into that in the next 5, 7, 10 years. But now we're very lucky that we can get in touch with you know, all the content providers, and you know, we have P&Is in certain places which are really, really useful. You know, and the LINX peering, you know, we're still in IX Scotland, but we're predominantly Manchester and London at 100 gig, and that's just fantastic. And there are other peering lands as well. We've got IX Leeds, NCL at IX. There are a few bits and pieces on those guys. You know, best of luck for those guys to grow and get more things happening, because power to the north, right? More investment into the north would be excellent. Thank you. So that's it in a nutshell. You know, we have a very good relationship with LINX. You know, the customers enjoy very, very good you know, experience on the network. We very rarely have big problems where they say, oh, I can't get this, or I've got buffering on that and the other. It just doesn't happen. And I think that's great, because from the customer's perspective, the internet just works, right? Which is good in one way, because the customers are really happy. They don't call your help desk. They just enjoy the internet. But the bad thing is, what about all of the hard work that we're doing? Nobody sees it, right? Because the internet just works. And it's only when there's a problem they go, oh, what's happening here? And then it comes to light again. But yeah, it'd be useful, you know, if we can educate everybody to understand, no, there's actually a huge amount of work that goes on behind the scenes in making sure the internet actually works. Anyway, I'm okay on time, aren't I, Jez? Very good. I was going to finish on this. Barn dogs, right? So in a rural environment, with all the engineers and the staff and the customers, dogs are everywhere, and they're a great companion. Okay, so these are a few of the barn dogs that we've got. That's my dog at the bottom there in white. He's called Barnaby, would you believe, for barn. And then just above that, you've got Walter, with I think that's Fiber the dog. So the dog is actually named Fiber. And sadly, he's passed away now, but he was an advocate in the early days for Barn. That's him catching fiber in that bottle. So he's waiting for whatever fiber to pop through, and then he'll radio back and say it's there. And look at the weather behind them. It's snow. We're out in all weathers getting this job done. It's got to be done in that way. And then on the right-hand side, you've got a dog that's very upset about the speed test. I don't know whether you can see, but it's about 2 meg. Very upset about that. And then underneath is when they've got 200 meg speed test, and very happy about that one. But yeah, we love dogs. They're out and about on the network, great companions. And I've rushed through that, but there we are. Any questions, I think?
Question over here.
Hi, I'm interested just on the basis of your trenching.
Yes.
Because I've heard a lot about how Google Fiber tried micro-trenching and the like, and it turned out to be generally a complete failure.
Okay.
How deep do you generally trench your fiber, and what sort of issues have you had with it?
Yeah, it's a great question. I get it almost every presentation, and it's a really good one, right? Because how is this being done? So we trench between 450 and 600 mil deep, right? So that's underneath the sod, and that's below you get to, it's above the rocks. And what we do is we work with the landowners and say, how are we going to get to you? It isn't a case of here's our plans and this is where we're going to dig and trench to you. It's a case of going to them saying, you want the internet, how are we going to get to you? And what they do is they come back and they say, well, we've got some drainage systems over here. That was done in the 50s, so that's that construction. Don't touch that one. Over this way, we've got, they know their land, so they can suggest the way to go. So if you look at it, our trunk doesn't go whoosh, like that and goes from A to B. The trunk goes A to B to C to E to F to G, etc. So it's a longer line, but who cares? Because what you get is you're following hedge lines, you're following scrub land that doesn't get used, it doesn't get farmed, and it's a real pain sometimes to install, but you get it out of the way. So then when the farmers are ploughing, subsoiling, reseeding, there's cattle in the field, they tend to stay away. And of course we get damage, okay, because land gets worked, so of course there's going to be damage, but what we have is a relationship with the landowners that says, if you break the cable, call us, and we'll just come straight out and repair it, and you're done. We don't charge you. Okay, so that means they call. So if there's a problem with strike on the cable, the monitoring system, the phones go mental, and then it's followed by a phone call. I'm really sorry, I've broken the cable, and then off we go and fix it. So yeah, I would say a huge amount of time goes into the discussions, the talking, about all of this, and then the actual doing is very quick. So yeah, works when you have that sort of methodology. Does that make sense?
Yeah. I mean, who owns the way leaves? Or is it sort of like a community ownership, or is it something that you own or whatever?
Yeah, so as a community benefit society, we are owned essentially by the shareholders. So the shareholders who are the customers, are the landowners who invest into Barn as a company. The way leaves are with us, so we go out and negotiate all of these. But again, it's it isn't a 100-page way leave. It's a shorter one which has all the fundamentals in it about who's responsible for what. If this happens, who's going to solve it? Lift and shifts, things like that. I want to develop land. Can you move the fiber? Yeah, sure we can. It's weighted towards Barn. So what I mean by that is if there's any breakages, we pay for it. Obviously, if it's criminal damage, that's a different story. But if people are accidentally breaking it, it's on us. Lift and shift, no problem, we'll move it. And if you have that relationship, then the discussion about way leaves, it just starts to flow rather than it being this big problem of legalese between you. You have to try and cut through that. All right.
Oh, we have a question from Neil.
Hello, Neil.
Hey, great build. It's great to see it. Also great to see you taking photos and videos of it, because I don't think we get enough visibility of what we do. More people should do that. My question was, on your optical platform, are you just using kind of optics from the router to drive that, or are you doing transponder handoff? Yeah,
so let's try and go back to, can I go back? I can't go back. So what we're doing is in the Junipers, we're plugging directly in the 400 gig coherent optics. Okay, and then we're plugging that directly into the waves through smart optics, the DCP-M40s, onto the line. But we also have breakouts where we might want to use 100 gigs. So what we'll do is we'll plug the 400 gig into the smart optics gear that will then break us out into 4 times 100, and then we can take those grey almost out into wherever we need to go. Beyond the main core, we're using the ACXs, the MX304s, and plugging directly into the line. Yeah?
Yep, great. Saving tons of money doing so.
Yes.
Oh, we have another question at the back. Ty's on his way.
With your network being really rural, do you have any out-of-band connectivity to your cabs, or is it a case of if something goes wrong, you have to dispatch an engineer out to it?
It's a good question. We struggle with that because the options for out-of-band for us is not an ADSL line, because, you know, that doesn't work. It's either going to be something like Starlink, which we use for our office for out-of-band, or it's going to be 4G. So that tends to be the one we go for, is, you know, a little, I think it's a Teltonica RUT 580 or whatever the code is, as a little box that you can put in with 4G, and then you can pop out the back of that, and then you can go into consoles and out-of-band, RFC 1918 and all your different devices, and then you can start to figure out what's gone on there. But yeah, 4G coverage isn't great where we deploy our cabinets. So we do actually struggle with that, which is one of the reasons why we at least have an east-west or north-south into every single cabinet. So they're not single-fed. Even the distribution ones for customers, they're dual-fed, because if you have a strike somewhere, you still want to be able to get in. But yeah, I don't have a full solution for that yet, but we try our best with, you know, all the options we've got to try and get back into the gear. Okay.
Okay, yeah. Well,
all right.
Thank you so much.
Thank you very much.
Thank you. Just before you go, I have a question as well.
Oh, sorry.
What I find really interesting about this whole process is that level of detail that you go into in speaking to the people. Sort of like, how do you want to make that work? I mean, how early on did that sort of come into the conversation? Did you actually start off with that as your main thing, that we know that we need the buy-in from the people that we're working with?
100%. Yeah, it was built from the ground up, talking to the people, figuring out what the user needs are and how we're going to get that done. It's almost an engineering project from the ground up, you know, and then it's how do you fund that and go to the people. We say, well, if we're going to do the best effort we possibly can, best engineering practices, talk to everybody, people will invest in it.
Yeah.
So yeah, right from the beginning,
Yes,
from the beginning.
Yeah. And also, it's great with the dogs as well, getting them involved.
Absolutely. They're everywhere. We have a dog-friendly office, and everybody can, you know, come in and out, and I think it's just great for morality, it's great for, you know, interaction, etc.
Yeah, okay. Yeah, great story. Lovely. Thanks very much for that,
Thanks,
Tom.
Jez.
Thank you.
Thank you all.